Good afternoon, everyone. I hope that everybody is doing really good today and that you had a fantastic weekend. We're coming into a short week. On Friday of this week, it's a professional development day for staff, so there's no student activities planned for that day. What we're going to be doing today is looking at applications of logarithms, and then on Wednesday's lesson, we are going to be looking at how we can use the laws of logarithms in order to solve exponential equations that you can't solve by using a common base. So today's lesson is a very short lesson. It's on page 13 of your lesson handout. And the goal of this lesson is that you become more and more comfortable working with logarithmic equations. And it turns out that in the real world, there's a lot of natural and scientific phenomena that follow logarithmic relationships. All right, example 1, the shade number of a welding glass is given by that formula. 7 multiplied by the negative log of t over 3, and then plus 1. T is the fraction or proportion of visible light that's allowed through the glass. And as an example, I'm saying that if only 1/3 of the light made it through the glass, then the proportion, which is capital T, would be 0.333. In order to safely view a solar eclipse using a welding glass, you need to use a number 14 welder's glass. What's the proportion of light that's allowed through that glass? What this question is asking us to do is the following. If S is equal to 14, then what proportion of light makes it through? So what is T? Well, we're going to take the formula. The formula is S equals 7 multiplied by the negative of the log of T divided by 3, then plus 1, and we're going to go ahead and put 14 in for S so that we can solve for T. 14 is equal to 7 multiplied by the negative log of T over 3, then plus 1. So when we start to rearrange this equation, the first thing we are going to have to do is get rid of that 1. We are going to have to subtract 1 from both sides. That's going to give us 13 equals 7 multiplied by the negative log of t over 3. And then we have to get rid of the 7 and the 3. We can get rid of the 3 by multiplying both sides by 3, and we can get rid of the 7 by dividing both sides by 7. In other words, if we take 3 multiplied by 13 and divided by 7, we're going to get the negative logarithm of t. Well, let's see what we get. .5714 equals negative log of t, and I'm just changing the negative log of t to negative 1 log of t. If we multiply both sides by negative 1, you get negative 5.5714 equals log of t. Now, how do we get t by itself? You get t by itself by remembering that when you see log of a variable and it doesn't tell you the base, that it's base 10, and then we convert it from logarithmic to exponential. If negative 5.5714 is equal to the logarithm, then that means negative 5.5714 is the exponent to which you raise the base to get the argument. So we're basically done. I have to multiply that number by negative 1, and then I have to raise as a power of 10 the result, and I get 2.68 times 10 to the negative 6. Now, we don't usually deal with scientific notation a lot in this course, but what this means is that t is equal to 0.000000268, that's like 99.99999 something percent of the light is being blocked. And that's the answer to example 1. Number 2, there's a logarithmic relationship between butterflies and flowers. In one study, scientists found that the relationship between the number of flower species in a particular region and the number of butterflies they see is given by that equation. And the relationship is that the number of flower species is negative 2.641 plus 8.958 log of the number of butterflies observed. And we want to determine that if the number of flower species is 25, how many butterflies would you expect to observe? We're simply going to put the number 25 in for f and solve this equation. So how do you go about solving this type of equation? I guess we're going to start off by adding 2.641 to both sides. To get 27.641 equals 8.958 log of the number of butterflies. Then we can divide both sides by the coefficient of the logarithmic term. So we had 25, we added the 2.641. Then we have to divide by the 8.958, and we get 3.0856. And this is equal to the log of the number of butterflies. Remember that a common log, which you recognize because they don't tell you the base, means a base of 10. And that means that b is equal to 10 raised to the 3.0856. Which gives us about 1,218 butterflies. And that's it. Very short lesson. There's a couple of questions from your textbook, and then there are a few questions that are attached to this handout that you should work on in order to get practice with rearranging these logarithmic equations. I hope you have a wonderful rest of the day. We will talk to you soon.